Let's talk about network security. I hope it doesn't come as a surprise to you that security is one of the top 3 concerns for network operators of today. If it does surprise you, then you can search the web and find data that outlines the extent to which security violations cause real damage to our networks in terms of time, money, and effort. So instead of trying to convince you that security should be top priority for anybody who runs, builds, or designs networks, I would like to share with you how our trustworthy ASR 9000 routers can help improve the security of your networks. So let's get started. Okay, so the first concept I want to introduce to you is called trust. Trust is more than security. Whenever we talk about securing a network, we think of ACLs or firewalls, or using BGP to black hole attack traffic. Now, all of this stuff is giving you tools to safeguard the network from threats, but with trust, we're saying you get to control the integrity of the device itself. You should be able to trust the device. We do this by building and maintaining the integrity of the ASR 9000 routers. So we don't just give you the tools to protect yourself from an attack. Instead, we are enforcing the integrity of your ASR 9000 router and maintaining it during runtime. So a trustworthy device like the ASR 9000 platform, not just a secure device, but a trustworthy device, should be the foundation of building a secure network. Now, when I say ASR 9000 platform, a platform is made up of both hardware and software. So trust also has to span both hardware and software for it to really make sense. You cannot have trustworthy hardware but software that's been hacked into or modified, and you can't trust a router that runs genuine software but on counterfeit hardware. Because hardware and software work together to enable the full capabilities of the ASR 9000 routers, we built trust into both the hardware and software on ASR 9000. Now, I hope you can see that trust is not just an idea or a concept. It is something tangible. It's something that you can verify. When the ASR 9000 is operational, you can ask for and get data from the router to check the integrity of the platform. You can also automate this process to get regular trust reports. So really, you can only trust the router if you have visibility into the platform's integrity. So when I say trust is more than just security, I want you to visualize trust as integrity of the platform, visibility into this integrity, and security tools that help maintain the platform's integrity. Now, let's look at how trust is built into the ASR 9000 platform, starting with trust in hardware. So it's a well-known practice to assign a unique device identity to hardware as a way to, you guessed it, uniquely identify that piece of hardware. This is called UDI, and it is typically a combination of the serial number and platform ID or PID on Cisco routers. It is used in a number of places like in inventory management to identify the hardware that's being shipped and so on. UDI is also displayed on the CLI when you query a Cisco router with show platform or ID info. But the problem with UDI is that it is not secure by itself. For example, it's easy for a malicious device to pretend to be a known device in our network simply by displaying the same UDI on the CLI. So depending on a CLI output that can be easily spoofed to prove the device's identity is not enough. There must be a way to securely identify the hardware remotely. This is where Cisco uses SUDI or Secure UDI. With SUDI, when the router's hardware is manufactured, a key pair is encrypted and bound with the hardware's UDI. This SUDI is then burnt into a tamper-proof hardware called TAM or Trust Anchor Module. So now, whenever you want to verify the integrity of a hardware module on the ASR 9000, like the route processor or the line card, you can remotely challenge the ASR 9000 device to provide its SUDI. This can also be done via the CLI, but this time the CLI fetches the output from the encrypted TAM location where the SUDI was burnt into the hardware during its manufacture. So the output of this CLI cannot be changed or manipulated easily. There are some other uses of the SUDI. Now we have a single source of truth for the device's UDI. Every software and hardware process accesses the SUDI from the TAM. This SUDI is also the basis of anti-counterfeit check on Cisco routers. A counterfeit device will not have the SUDI burnt into the TAM, so it's a very easy check to perform and identify counterfeit hardware. SUDI can also be used for securely communicating using the management plane and for bootstrapping routers with config during ZTP. One other use of SUDI is for Cisco to monitor its supply chain by mapping the number of devices manufactured out of each site with the number of SUDIs allocated to that site. So as we've seen, SUDI is the basis for hardware trust on ASR 9000 devices. Now let's understand how trust is built into the software. On ASR 9000, iOS XR is the operating software, and every iOS XR image is digitally signed by Cisco. Image signing is a two-step process. First, the code is run through an algorithm to produce a hash value. Any changes in the code will result in a new hash, so this hash is unique to the particular code in the iOS XR image. This unique hash is then encrypted with a Cisco private key and is delivered along with the iOS XR image. Now, when the ASR 9000 boots up with the iOS XR image, the boot code will check this digital signature and only genuine iOS XR images will be allowed to boot up on ASR 9000. Along with this digital signature step, iOS XR itself is a secure, protected software. It uses all the best software design practices like memory protection, modular processes, and microkernel-based architecture. Each process runs in its own protected memory space, so corruption is impossible. Applications are containerized, so any failure in a particular app does not interfere with the core of the operating system, making the router less vulnerable to exploitation. So iOS XR itself is a secure operating system. Along with this, iOS XR offers a number of security tools in the form of features that you can customize to use in your network to fight against threats. To secure access to the router, we have features like AAA, Radius Plus, SSH, and Type 6 encryption to protect the router's data assets. ASR 9000 also supports DDoS and advanced ACLs, along with control plane policing and protocol security features. ASR 9000 also supports MACsec to secure data on the wire and BGP FlowSpec to track priority flows. These are just some of the security features that iOS XR supports. So as we've just seen, ASR 9000 provides you with tools not just for security, but to build trust in your network. In the next video in the security series, we'll see how this trust works in reality. Trust in action, if you will. If you like what we're sharing here on the Cisco ASR 9000 channel, I hope you'll consider subscribing. Thank you and see you in the next video.